Okay, so for problem B, you have to calculate the pH of a 0.175 molar solution of HOCl. So I drew an ice table and I wrote the equation on top of the ice table, and then I filled in what information we had. So there was the 0.175 molar, and then the H2O is a liquid, so none of the values count. And then there's the zero values for the hydronium and the OCl negative. And so since that's all we have to use x's. So this is plus x subtracted from x. And then we can assume that this value is 175 molar because the x's value is going to be small. So if we set that up, we end up getting the Ka of 5 molar. And so since we know the Ka, we can replace it with 3.2 times 10 to the negative 8th. And we do the algebra, and this becomes x squared. And so we multiply by the 0.175, they cancel, times the 0.175. And then our answer is our answer is 5.6 e to the negative 9th equals x squared. So if we take the square root of that, we are left with 7.48 e negative 5. That's our x.
So C asks for the net ionic equation of HOCl and NaOH. Well, we know that HOCl is a weak acid and NaOH is a strong base. So strong bases will split up into their ions, but HOCl is a weak acid, so it won't split up. So when you split it up in the equation, you have extra spectator ions because this is alone, so these won't cancel, but these will, leaving you with a result of this in the end for your net ionic equation. So for 2a, they asked for us to give the equilibrium constant expression for the dissociation of HF in water. So first we wrote out the chemical equation, and we got that your reaction ends in a hydronium ion and a fluorine ion. So then you put, to get your equilibrium expression, you put your products over your reactants. So because H2O is a liquid, it won't be on the bottom, but you will have hydronium ion, fluorine, and HF.
So on to B, we are looking for the molar concentration of H3O. We are given Ka, and that's 7.2. And we are given HF. So we set up the equation as concentration of H3O times the concentration of F divided by concentration of HF. So we just plug in. Then on the top we assume that H3O and F are equal, so that's equal to x squared. Then we multiply by 0.4, and that cross. Then we multiply by 0.4, and that cross out. And on the other side was equal to 2.88 times 10 to the negative 4. If we take the square root of that,
that's nice. Where's your chair?
and x equal 1.7 times 10 to negative 2. So on to B, we are looking for the molar concentration of H3O. We are given Ka, and that's 7.2. And we are given HF. So we set up the equation as concentration of H3O times the concentration of F divided by concentration of HF. So we just plug in. Then on the top, we assume that H3O and F are equal, so that's equal to x squared. Then we multiply by 0.4, and that crosses